Here we're going to learn how to balance a redox reaction. And while the video of this will be me reading off the rules, perhaps it is more useful for you to go to the worked problems and see how several of these types of reactions are balanced in person. However, keep in mind that you want to have a copy of these rules around for the first couple of attempts at balancing a redox reaction. So the first thing we need to do in a redox reaction is determine what the heck is being oxidized and reduced. So we have to look for things which are going to have different oxidation numbers. Remember that oxidation involves something losing electrons, and reduction is something that gains. If you want to think about an oil rig where oxidation is loss, or oil, and reduction is gain, rig, is one way you can use to keep track of what's being oxidized and reduced. What you have to do is break up the two components, that is the material being oxidized and the material being reduced, into a half reaction. When you have a half reaction, you're only dealing with a part of the overall reaction at a time. The first thing to do when you balance a half reaction is balance all elements except hydrogen and oxygen. Then, after those elements have been balanced, we balance oxygen by adding water to the opposite side. And then, to balance the hydrogens, we add protons, or H+. Once we check to make sure all the elements are balanced in the half reaction, we then need to deal with charge. To deal with charge, we need to make sure both sides have the same overall charge. Note, this does not have to be equal to 0. To balance charge, we add electrons. We always add electrons to bring down the charge of one side so that it's equal to that of the other. We add negative charges. We don't do any subtraction. We're adding negative things. Once you have each half reaction balanced, you must then find the number of electrons that are in each half reaction and find what number they have in common. To find what they have in common, use the least common multiple, and then multiply each half reaction by a constant to get to that least common multiple. Once you have the same number of electrons in both half reactions, go ahead and add both half reactions together and subtract out things that appear on both sides. Then double check that your equation is balanced according to mass and elements, and in terms of charge on both sides. If this reaction is being done at basic conditions, you'll want to add equal amounts of OH- to both sides of the equation. This will cause H pluses to cancel out and make water when you have H plus and OH minus.